I'm Anil Kumar sharing with you a test question on transformation of graphs. We'll transform the function whose graph is given right there. I would like you to pause the video, copy the graph, and then sketch the transform function g of x, which is equal to minus f of 2x minus 4 minus 1. Well, whenever you are given a function like this, you should write it in standard form where x should have leading coefficient of 1 only, right? So we'll factor out 2. So we could write g of x as minus f of, within brackets, we'll factor out 2 and we get x minus 2. Now clearly you can see that the function has been translated 2 units to the right? So it is reflected on x-axis, translated 2 units to the right, 1 unit down after doing horizontal compression by a factor of half. Now that should give you transformation of points. So we'll actually sketch the graph in one step after calculating image points. So if x and y are the points on the original graph, then the transform function will have points where x value will be half. Then we have to add 2, right? Moving 2 units to the right. As far as the y values are concerned, they have to be multiplied by negative 1, so become negative y, and then we'll take away 1. So that gives you coordinates of image points. So let us first write down all the coordinates. So for A, we could write this as minus 4 minus 4. For B, we have minus 3 0. For C, it is minus 1 2. For D, 1 2. For E, we have 3 0. And for F, we can write 4 minus 1. Now applying the transformation, we can rewrite all the image points. Once we get them, we can plot the transform function. So we'll do half of the x values. Minus 4 half is minus 2. When you add 2, you get 0. As far as the y values are concerned, we'll do negative and then minus 1. So 4 minus 1 gives us 3. The next value is for B. We'll write A dash for the image of A, B dash for image of B. Half of minus 3 is minus 1.5. When you add 2, you get 0.5. The y value becomes minus 1. As far as C dash is concerned, half of minus 1 is minus 0.5. That means when you add 2, you get 1.5. The y value, minus 2 minus 1, gives us minus 3. Image of D. 0.5 plus 2 means again 1.5. Let's redo. Half of 1 is, so in the previous case, it was minus 0.5. So when you add it, you get 1.5. Here, 0.5 plus 2 gives 2.5. Yeah. The y value will be minus 2 minus 1, which is minus 3. For E dash, we get 1.5 plus 2 as 3.5. 0 minus 1 gives us minus 1. And the last point here, F dash. Half of 4 is 2, plus 2 is again 4. Minus 1 becomes 1. 1 minus 1 is 0. So those are the image points. Now let us sketch them one by one. We'll also check our point using standard transformation. Minus means reflection. So basically, if you look at it, let's look at A. If you reflect it, it goes at this position. Then we have to do horizontal compression to half, so it comes at minus 2. And then we have to translate 2 units right, 1 down, 2 units right, 1 down. It should come at that position. So the final coordinate is 0, 3 as shown. So that is your A dash. Do you see that? Now let's look into the second point. That means this point is perfectly fine. 0.5 minus 1. So 0.5 minus 1 is right there, which is B dash for us. C is 1.5 minus 3. 1.5 minus 3 is right there, right? So we get C dash. This is B dash. D dash is 2.5 minus 3. So 2.5 minus 3 right there. E dash, this is D dash. E dash is 3.5 minus 1. 3.5 minus 1. And then F is 4, 0 right there. So we get a transform function. Joining them, we get the graph, which is kind of like this. Correct? So that becomes the graph of the function. So we can write this as E dash and F dash of the transform function. So I hope the steps are absolutely clear. So what we did was we found the image points with the help of transformation and straight away plotted our graph. You could actually check the points also, as we did with A. Let's do with F. Once you reflect this point, it will be right there. And after reflection, horizontally compressed by a factor of half, it comes right there. Then translate 2 units right, it goes back to 4, and 1 down comes at the x-intercept. So that is correct. And the shape is kind of reflected and horizontally compressed as shown. So I hope that makes sense. Now in such questions, sometimes you may be required to find domain and range, right? So domain and range you can write for g of x, right? So that could be a part of your question at times. I hope that helps you to understand how to sketch a transform function using image points. Feel free to write your comments and share your views. And if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.